Overview of the multi-technology wireless access networks. Here, in this overview of the multi-technology wireless access networks contain 3 GBB dual connectivity and multi-radio dual connectivity. 3 GB access LWA NR/LTE NR/LTE 3 GB GNP per ENP1 ENP2 LWA through IEEE 802.11. This is the 5GCCP UPF 83S data network connected through N6. Here connected in 3 GBB GNP enabled to connected to UPF through N3. Here also non-GBB access untrusted, trusted, untrusted connected to non-3 GBB IWF, trusted connected to TNGF. This non-3 GBB IWF connected to UPF. Here also TNGF connected 83S. This is Wi-Fi L5 Li-Fi Wi-Fi Li-Fi integration here. This is not 3GP access to 5GC. Already we have seen. Okay, then next enhanced ATSS. Here actually in this figure, once the Wi-Fi and Li-Fi networks are integrated in order to compose a single non-GBP access network, the existing mechanism to integrate 3 GBP and non-GBP networks such as N3.1WF or Trusted Network Gateway function can be used in combination with 3 GBP access traffic steering, switching, splitting ATSS framework to have an integrated 5G Wi-Fi Li-Fi network. Figure 3.1 illustrate overview of 3 GBP and non-3 GB based multi-wireless net access networks. This one only Wi-Fi, Li-Fi integrated here. Both are integrated here. And here what we got. Yeah, Ethernet segment. Here this one. Yeah, practical approach on integrating Wi-Fi Li-Fi networks within a single SDN enabled layer. 2 L22 network proposed 3 the reference 3 to 3, 3 to 4 with the following motivation in mind for using customized L2 SDN network to provide the ability to control the path followed by packets belong to different slices within the L2 segment with fine granularity as compared to a standard IEEE 802.1 Ethernet segment, and to support seamless mobility, meaning that when user devices roam through the various Wi-Fi and L5 APS connected to the L2 SDN network, forwarding paths can be automatically updated. That's all here. Then enhanced ATSS. 3 GBP releases 16 access traffic steering, switching, splitting ATSS. A for access, T for traffic, S for steering, another S, second S for switching, third S for splitting. Framework considers the steering procedure to send a traffic flow through 3 GBP 5 GNR and not 3 GBP network integrated Wi-Fi Li-Fi network in 4 different modes activity standby. As active standby, smallest delay, load balancing and priority based. When either the activity standby or priority based steering mode is selected, priority information element is used to indicate at which the condition 3 GBP or non 3 GBP access network is used to transmit the data flows. However, when the load balancing steering mode is selected, weight factor, a weight factor is used to indicate the proportion of the traffic to be forwarded to 3 GBP and non-3 GBP access networks. The traffic steering, switching and splitting strategies enforced via ATSS rules are based on predefined values for either all traffic types or some specific traffic types such as UDP, DCP to a specific IP address or port. For example, if the load balancing steering mode is selected, a predefined percentage value has to be used for 3 GBP and non-3 GBP access networks such as 20% for 3 GBP and 80% for non-3 GBP. In another example, the priority-based steering mode can be selected to prevent congestion over 3 GBP network. Then high priority is assigned to non-3 GBP network to offload the 3 GBP network traffic. All these rules are pre-constructed and ordered in a way that as long as a data flow matches a rule, the data flow gets routed according to this rule and the remaining rules are not considered. While traffic is routed according to a specific rule, sudden changes on the network status such as link availability due to CSI fluctuations, link package, link package or network congestion will not be incorporated to traffic routing. In this context, an enhanced ATSS framework named EAT3S is proposed to resolve the issue by introducing another steering mode named real-time steering mode. The real-time steering mode is described as the ATSS rule with the highest priority rule 1 and will be adaptive to link conditions and network status. An example flowchart for ATSS rule with EATSS. EAT3S real-time steering is shown in figure 3.2. Based on the given flowchart, if there is a congestion on 3 GBP network and the load balancing steering mode is used to enforce 80% for non-3 GBP network. The real-time steering mode rule modifies overrides the weight factor for each access network to 40% for 3 GBP and 60% for non-GBP to optimality. Utilize available 3 GBP and non-3 GBP access networks, aka the integrated 5G Wi-Fi Li-Fi network. Figure 3.2, an example of the proposed ATSS rules with the EAT3S real-time steering mode. An example of the proposed ATSS rules with the EAT3S real-time steering mode. Blue rule boxes represent the E83S rules and the gray rule boxes represent the existing ATSS rules. RIS is and the AI based radio access optimization, bringing to fruition the notion of AI-aided D-band wireless beyond 5G networks entails the challenges of devising a flexible and powerful machine learning language-based wireless network optimization framework, introducing novel propagation and channel modeling principles and developing cutting-edge technology components such as a beam forming antenna arrays, metasurface based intelligent materials, RF front ends, baseband processing, medium access control protocols. In this section, the technology and the concept of RAN with the metasurface is introduced and then three deployment scenarios for it are discussed. RAN with smart surfaces. Risks are expected to significantly improve wireless systems. Okay. Performance when the line of sight LOS path is either permanently or temporarily blocked. One of the greatest challenges in the reconfiguration of the RIS is beam tracking, since the reconfiguration often needs to be realized in a faster pace due to the possible movement of the users. In addition, due to the challenging nature of pencil beam tracking in scenarios involving movement of users, it may be necessary that the beam width of the transmit and receive antennas is increased so that the possible misalignments do not cause a substantial drop in signal quality. RIS can independently configure the phase shift of the incident electromagnetic EM wave. This motivates the investigation of two key functionalities of RIS, namely the beamforming and broadcasting. An illustration of the scenarios corresponding to these functionalities is provided in figure 3.3. Even without reconfiguration, the metasurface can be used to overcome the limitations of the NLO scenario by reflecting and focusing waves to the desired location or direction. Moreover, it can be used for enriching the multipath profile by reflecting waves into several directions beyond obstacles, creating multiple reflection in the indoor scenario. Here, RIS assisted beam forming in figure A and RIS assisted broadcasting in figure B. Here beam forming, RIS assisted beam forming, access point, dynamic blockers, fixed blocker, move, mobile user. So making. Okay. This is making assisted performing. RIS assisted broadcasting. Mobile user, fixed blocker, dynamic blocker, mobile user 2, mobile user 1, mobile user 3. So RIS assisted broadcasting mobile user to and up to M. The RIS assisted beamforming scenario is when a signal transmitter communications with the receiver through air is that